Hello, today we're going to talk about KRISSBERT, knowledge-rich self-supervision for biomedical entity linking. Entity linking is the process of matching a mention that we find in some text to a record in an ontology, such as Wikipedia or UMLS. The mention disambiguation is critical and even more critical in biomedical applications because it's very important to be as much concrete as possible. And the ontology that we are going to use to do this comparison between the mentions and the records is UMLS, a huge representative ontology for biomedicine with more than 4 million entities related to medicine. So what are the motivations of this paper? First of all, try to address the ambiguity and the variability in biomedical domain that we find in this text. Second of all, to propose a zero-shot method that can improve already existing ones, such as SapBERT, by including the entity context. And third of all, to use an ontology and a self-supervision method to enable a scalable system that can deal with the scarcity of data that this domain suffers. First of all, what they do is that they take an entity list from UMLS together with a semantic hierarchy and some descriptions to enrich the results. And PubMed, they take some abstracts from PubMed, medical repository of articles, and from them they take over 1.6 billion mentioned example. After that, what they do is that they encode these mentions using their left and right context. And then for each batch, they take 2 examples of similar mentions, what it means corresponding to the same entity, and the rest of them are not related to these 2. And the same for each pair in the mini batch. And after that, they compute contrastive loss, the most popular one, which is info NCE. And also they enrich it with what they call entity-centered references, which are context vectors compared against entity-centric vectors corresponding to that entity, which are composed by STN, which is a semantic code inside of UMLS, the type of entity, for example, disease or symptoms, and the alias for that entity. So they combine together these two losses, and they train a system that learns how to separate mentions which are not related to similar concepts and stick together those which are similar. From here, they obtain candidates for each mention that we call prototypes. And these prototypes are passed through a cross-encoder that re-ranks them using a cross-encoder, which basically concatenates both the query mention and the prototype and encode them and pass them through an MLP classifier, obtaining a similarity score between 0 and 1. What are the results that they obtain? Well, they do this benchmark using unsupervised and supervised entity linking models in literature, and they evaluate them on 2 kinds of corpora. First of all, smaller ones, which are composed by only one type of entity, diseases or chemicals, drugs, etc., and a second set of bigger data sets with more variety, more realistic documents, discharge summaries, or med mentions, which is basically something similar to PubMed, and Share, which contain a lot of diseases. And what they observe is that, first of all, they obtain the biggest improvement for generic datasets, which is very important because it is easy for the system to detect using strict matching or similar approaches to detect diseases or drugs in a corpus full of diseases and drugs. but it's not that easy if this information is mixed with another types of entities. And the second thing is that the self-supervised approach, without using any gold standard, any labels, does it better not only than the unsupervised methods, but also the unsupervised ones. In lazy supervision, they call lazy supervision to using as prototypes not only the self-supervised mentions that were obtained during the training, but also the gold standard. And by combining them, what they obtain is similar or even better results than state-of-the-art for those data sets in the same task. They, in NCBI, BC5, CDR, and med mentions, they do it better than the current state-of-the-art. In the case of disambiguation, we can see that the results are promising because if we take only the ambiguous mentions, we call ambiguous mentions to those that cannot be directly matched using strict matching dictionary lookup. We see that KRISSBERT clearly outperforms SapBERT, being this different highly correlated to the amount of ambiguous concepts. And here we have an example of this behavior. Here we have 5 days of oral prednisone in treatment of adults with mild to moderate asthma exacerbation. And in this case, SapBERT predicts mild. They have as candidates mild severity of illness code or mild adverse event because it doesn't understand that asthma is following this sentence. But in KRISSBERT, as we encode the whole, not only the word, not only the mention, but also the surrounding entity context, it quickly identifies that it's related to mild asthma. This is very powerful. And what are the most important results in the design? Here we have an ablation study of the different elements of the design. What we can see is that this mention pair contrast self-supervision is what really improves the base model. Another thing is that here we can see that the difference between initializing using BERT or PubMed-BERT, which is the one that they use, also improves significantly the results. So what are the conclusions here? First of all, they could satisfy hypothesis 1, showing consistent performance even in the case of med mentions where ambiguity was present. The second thing that they show is that with a zero-shot method, you can obtain results as good as a supervised system. And finally, that self-supervised system improved the already existing one thanks to this management of the context, and also most of the state-of-the-art system, self-supervised system for the corpora used in this work. Another thing is that they have offered a very promising tool for low resource settings. For example, if we want to train a model in biomedicine in Spanish language, we could replicate this thing using PubMed in Spanish, a translation, or using some articles from a medical database, a medical article database such as Cielo, and just replicate the process and obtain promising results. It's something still to be done. Lazy supervision technique that ensures that not only the self-supervision, but also if you have some annotated mentions, you can include them and it works even better. It improves the behavior. But also it has some limitations. For example, when we see this graph, we see that the accuracy at 1 compared to the accuracy at 5 is way worse, being this difference of almost 20%. This is due to the quality of the re-ranker, and this can be improved just choosing a good pre-trained re-ranker and also applying contrastive learning to train the existing one. Another limitation is that it doesn't do it very well when we have mentions corresponding to different types. For example, procedures are very difficult for the model to distinguish them from the rest of the types. As we see here, protein expression and expression procedure is a confusion that we can find from KRISSBERT, and also creatinine measurement and creatinine. So a solution that we propose is to have different models for different types using the ontology branches and training each of them and then combining them in doing a model ensembling. And this is all. Thank you.